Well, everyone, I have to report that the in the application that I'm using it for, the MiniPRO model TL866A has failed me. Now, it seems to be a really nice device, and I've made some modifications to it, which we're not going to go through today because turns out that this modification didn't help what I'm about to talk about, but the next one did, so let's get there. What am I doing that this thing failed me? Well, I am programming the MBM2716 EPROM, right? The Fujitsu MBM2716. Some vintage chips right here, and I'm wanting to program those. And as it turns out, if we look over here on the screen, we will see some specs about the MBM2716. I think this is a fairly original 20-30-year-old data sheet. And let's have a look here. And I'm just going to point right to the issue that I've identified. Pin 21 is the VPP. Now, if we go to the support, which the MiniPRO 8 version 8.65 software does have, and that's what I'm using here, we go to Fujitsu MBM2716 right here. Okay, if we were to go to all of them, we'd look for Fujitsu, and if I search for devices, we have all kinds of Fujitsu here. Fujitsu, right? We have the 2716, the 27128, blah 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 blah, all this stuff. Well, this is the one I'm working with. All right, so let's have a look. Let's select this one and see what we get. Well, look here. VPP voltage, the default here is 12.5 volts. Verify is 5, write is 5, and pulse delay is 500 microseconds. Now, all of that is fine and good, but let's have a look at our spec sheet. VPP is on pin 21. What's the voltage supposed to be? Well, I found that if you scroll down here to page, looks like 4 of 5 on the spec sheet, it says very clearly, let me zoom in on this, make sure we all can see it. The program mode is entered when plus 25 volts is applied to the VPP pin, when OE is at VIH. The address will be programmed, and so on and so forth. So clearly the VPP takes 25 volts. There you go, 25 volts. So, let me make an adjustment here. Ahmed, you can cut out that dead area. That kind of stuff is exactly the kind of thing I want you to edit out. The programming was entered at 25 volts. Well, let's have a look to see if the programmer will even support that. VPP voltage, well, the default is 12, so that certainly looks wrong. Let's see if we can go up to 25. Well, we can only go up to 21, but the question is it going to be good enough? And I found that the answer is almost unequivocally no. If you look at some of my previous videos on programming the MBM2716 using the Intel version, I found that to be a fairly miserable failure. And if I persist with the programming and program every bit again, and I click the retry about 100 times, it might get through it, but then with how many errors? So we had instances where it does a compare on the chip that I program. It compares 100% accurate to the source file, but it doesn't actually run in the device, and it clearly fails in the device as opposed to the program that's supposed to be written on there. So there you go. We're having all kinds of fun with this. So all of this said, we're going to have a little bit of look at how we can actually modify this thing to get it to successfully and easily program the MBM2716 Fujitsu chip at 25 volts. And I had to make a modification, and it's my second modification that I think gave us the right answer here. So let's go through that so that I can show it to you. The idea was to bring the VPP voltage all the way up to 25 volts. So I thought, well, all right, so we have 21. So if it really is 21, we only need 4 more volts, right? So basically 3 AAA batteries will do it. However, it seems that the actual output voltage on this when programming is not exactly 21 volts when set at 21 volts. It's more like 16. So I thought, well, let's see what we can do here. So what I'm going to do is I'm going to open a file, and we're going to write that file. I think we're going to go with this. There we go. All right, so here's the file that I want to write to a chip. And so I believe this one is blank. I guess I should have checked that first, right? Device, verify. No, not verify. Device, blank check. Control B. And sure enough, device is blank. All right, good. Still have the file loaded. All is well. Now, if we're not even going to bother testing this on lower voltage, not yet. And I guess what I meant to do is to put this in here. I have a chip modification device that I made, and let me show this to you. I guess first things first, I'm going to pry this chip off here very gently. This MBM2716, and I'm going to go through this. This is what I'm going to call an adapter and tester. It's just a 24-pin IC chip. 24-pin socket, and a rather cheap one at that I got from China. But we're going to have a look at the modifications that I made to this. Now, you can see I soldered some things to the side here. The first thing I did was I put on some testers because I thought, well, this is a lot easier just to connect test wires. If I'm going to do soldering and modification to this, at least I'll be able to connect my tester up much more easily. So I've superglued and soldered a lead right onto pin, I believe that's pin 12, which is supposed to be ground. Let me check on the data sheet here, and let me zoom back out to a reasonable size. And the data sheet says that 12 is VSS, which I understand to be ground. So there you go. So that's the ground that we're using for test right there. Now, what else do we need? Well, pin 21 is the VPP, and so this is what I'm working with here. So over here I've made some modifications to pin 21, and they're pretty important. What I've done is down here on the bottom I've taken this pin and I bent it out. Let's see if we can see that very clearly on the camera here. I've bent it out this way. And then what I've done is I've taken basically the lead to a resistor, very thin, solid, probably aluminum wire, and I've created a new lead. And what I did was I simply soldered that into the side. I used the soldering iron to melt that into the side, and I bent it. I bent it down here into the position this used to go, and it almost looks like those touch, but they don't. So if I get good enough light here, I believe we can see it fairly more easily. I want to make sure we have good focus. We can see that doesn't actually touch. See it there? It doesn't actually touch. It just goes down and then up into the position that the other pin used to be. So as you look on the side view, you see that it's definitely thinner than it used to be, because that's a wire and the rest of these are the actual socket pins. But it does, you know, fit the ZIF socket just nicely because it's in the right position. And I checked, and there's no connection between the two. So basically, I have this wire, which is basically the output of the programmer, and then I have another wire coming in with a 1N4003 diode. That's just what I had a surplus of, so I thought, well, that's a pretty average diode. Let's use that for general purpose. And then, you know, what I've done is I have two more test leads here that I've soldered on. This to the lead 21 that's coming off of the programmer itself, and this right after the diode to check the voltage as I'm pumping it back in to the chip itself. Nope, the other way around. I got that backwards. The yellow one right here, this is the lead as we're testing right off the programmer, because this newly designed pin I pulled off the programmer, and so this is testing the voltage as it comes off the programmer, and then this is testing the voltage as it comes back from an additional power supply. We're going to get to that in a minute, and this is the 1N4003 general purpose diode that I talked about. If I called it something else other than a diode, I'm going to need to edit that out because that's just embarrassing. Okay. Alrighty. So basically we'll be able to test the programmer output voltage by using the yellow lead here. And we'll be able to, by using the yellow lead here, the programmer output voltage by using the yellow lead. And then we'll be able to test the new voltage that I'm pumping into the chip by using the gray lead right here on my additional power supply modification. Now, what else have I done here? Well, I decided, and because I recognized that 4 volts wasn't going to be enough, and I'll show you why, I said, well, let's just go to a 9-volt battery. And then let's use a slightly lower voltage setting on this so that it all comes right out to 25 volts when we measure it. And it turns out that this works out really, really nicely. Now, I ordered on eBay some proper connector clips, because as you can see, this is not a proper connector clip. I simply soldered those things on there, and you know, that's kind of a crude hack. But hey, when you need to get something done, that's sometimes what the situation calls for. So, and then what I have here is this is just a single pole double throw switch underneath the shrink tubing here. Basically, when it's in the off position, here, yeah, that should help with focus. When it's in the off position here, then it simply connects the purple and the gray here, the purple and the gray wires, which are taking me over to basically it connects. Basically, it just connects the end of the diode. It connects the end of the diode that is not going to the pin of the chip to the purple wire, which goes to, no, I guess the other way around. The purple wire, which goes to the chip, to the end of the diode, which comes off of the programmer. Okay, that's how I've wired it. So I keep forgetting it. The top comes after off of the programmer, and the bottom, the purple one, actually goes back to the chip because of the way I have it wound into that chip socket there. Okay, so now that I've gone through all that, let's do some tests and see what we get there. So this is in the off position. It's basically just you know, going through. It's basically the voltage is going through the diode, but we can still measure the voltage right off of the programmer, because I have a lead on each one, the yellow and the gray there. Okay, so let's plug this in and try it. This is a little bit clumsy because I got the heavy 9-volt battery clunking around here, and I don't have a nice enclosure for it, but I might do something where I attach it to this a little bit more elegantly and make it a permanent part of this particular device here, so that I can take it on and remove it nicely but modularly without wires and weights hanging all over the place. 9-volt batteries are really great weight. I found that out years ago. Okay, looks like it fits well in the ZIF socket right here, and let's plug in a chip here. And before I do any testing, I'm going to open the programmer software here, and I'm going to do a device blank check. Make sure I put in a blank one. Blank check right over there on the PC, and yes, sure enough, device is blank. It verifies. Okay, so far so good. Now, these test leads, I even did some modifications to my X-Tech meter here. Put that on DC volts, and I soldered in these, you know, test lead inputs. I thought this was kind of a neat little addition to my meter, because I'm constantly wanting to check these things, and instead of using alligator clips, now I can just plug them in from all of my test circuits. So I kind of like that little modification. I did that just for this one. Isn't that cool? So the ground, nice right here in black. Let's connect that to the ground right here. And the first thing I'm going to want to do is to test the programming voltage coming off of the programmer, which is the yellow. So the yellow comes off the programmer. I probably should mark this somehow with a label, but we'll get there. We will get there. Yellow comes off the programmer. All right, let's see what we have. All right, let's make sure we can read the meter without any glare, and we can. So it's just reading spurious signals now, bouncing all over the place with the millivolts. So what I'm going to do is I'm going to set the VPP voltage for 21. This is off, so the voltage that's going to the chip is reduced a little bit by the fact that it filters through this diode. Just the way I designed it. I probably could have put the diode on the other side of the switch. I didn't. Sorry. I thought of that afterwards, but this still works. Okay, so coming right off the programmer, we have this, well, it's easier to find out what the the drop in the voltages across the diode there anyway. So we'll be checking both. So this comes right off of the programmer, the yellow. So here we go. I'm going to hit program here. There's the program button. Now I expect this to error out. So here we go. And program. And as we can see, it instantly errored out. And so this is going to be kind of tricky because it turns on and turns off again because we're erroring out on this thing. So what I'm going to do is we're going to try something a little bit different. We are going to do this test a slightly different way. I'm not sure if it actually wrote anything. And yeah, it looks like it wrote the first bit here. See that 5F instead of FF over here on the PC? So it looks like it wrote the first bit, and so I've already partially programmed this. So forgive me for the bad test as I'm just trying to figure this out. I'm going to pop this chip out and I put it in the other blank one. And I'm going to show you something different. There we go. Plug in this other blank one. All right, let's do a read on this one. Make sure it reads blank, and then we're going to do a blank check on top of that. The reason I did a read is I wanted to clear the the input file here so that it is all double F's, all blank. So I'll do a device program check, blank, and we have a device blank check. Now, in this case, what I'm going to do is, in order to get this thing to actually program for a while, I'm going to program it all blank. It's going to spend a little bit of time trying to program it, but it's not going to need to do anything because if all of the bits are at 1, then the voltage doesn't need to push any of them down to 0, and I understand that from talking with other people. This is how that works. I'm not an engineer and I don't have a great deal of experience in this, but that's how it was explained to me. It pushes all the bits down to 0 where it needs to, and that's how the programming works. But when they're erased, the window is exposed to the ultraviolet light to erase them for however much time, 20 minutes to an hour. It basically lets all of the bits pop back up to 1. That's the best layman's terms that I can get on how these things work. I'm sure some of you watching this now who are engineers will probably laugh at that description, but sorry, it's how I understood it, so I thought I would share that with anyone that thought that was helpful. All right, so right now our goal is to check what the programmer is putting out to this chip, set on 21 volts, if we program it. So we're programming it at blank, but we still should have the same output voltage. So we're powered entirely by USB here. And so let's see what this thing puts out. Here we go. And program. See that it jumped up to 25 and then it went to 17. And then a program said successful over here. So it programmed just long enough. It spent just enough time programming that we could see it popped up to 20. It popped up to 25 for just a second, but then it dropped back down again. So it was not sustaining 25 volts. Let's try that one more time. See that? So it looks like it hangs out at 17. So even though it's set for 21, it really, about 17, 17 and a half. I'm going to keep hitting it again so that we can see it. Again. See it? Exactly. One more time, just for fun. Okay. So the battery should be providing 9 volts. Great. Well, let's do a little math. If 21 is actually putting out 17 and a half, then I only need 8 volts, right? Well, it's pretty close to there. I mean, 9 volts is going to be 25 to 26. So what do you say we just go for it? We're going to be a little bit high. We're going to be a little bit high initially. If it jumps up to 25, 25 plus 9 is going to be in the 30 volts, but it shouldn't be beyond the tolerance of this thing, just for a second. I don't think I'm going to burn the chip out. These things are pretty robust, I've found. I accidentally put one in the application the wrong way, and I watched one of these little pins in here glow because I had applied voltage to a pin I didn't. And, well, the chip still erased and then worked flawlessly when I programmed it later, after solving this. So I didn't even destroy a chip when I did that. So these things are pretty, I think they're a little bit more indestructible than we're all taught to believe by putting them in static bags and all of that stuff. Anyway, so let's see here. if we were to look at the DCC characteristics, here we go. Right here on page 5 of the spec sheet, we see the VPP programming information on page 5. BPP minimum doesn't say anything, so I'm glad we read that in the narrative above. The maximum there is 30 volts on the VPP pin. So, you know, we'll be going up a little bit beyond that, but what the heck? Otherwise, it's not going to program right. So let's just go for it. Let's see what happens, right? I've got plenty of MBM2716s to program, so I don't have a shortage of those. So if I accidentally blow one out, well, I learned, and that's how I learn. All right, so we're going to do this now. We are going to turn this thing on. And so now I've got a spurious reading here of negative 3.9 volts. Not sure why. And, well, you know what I'm going to do? I'm going to do a different test. I'm sorry. I got ahead of myself. Let me change, well, that's still off. Let me try programming through the diode, which is going to give us a little bit of a drop. So I'm going to go to, this is right off the programmer, to this is the programmer through the diode that I put in here, which I decided I needed so that I didn't pump you know, electricity backwards through this thing and blow it out, or backwards to the chip and blow that out. Made sense to me. Maybe it's not necessary, but it made sense to me. All right, and of course the polarity. I neglected to mention that the polarity I've hooked this up to is the positive end goes to the chip, and the negative end goes to the pin 21 coming off of the programmer. So basically, I've put the 9-volt battery in series with the voltage that the programmer is putting out. And so this isn't any different than putting batteries in, you know, 3 batteries or 4 batteries in a device and then having the voltages add your 1.5 volt pen light batteries, AAA or AA. You put those positive to negative in the little holder there all the time. And so 1.5 plus 1.5 is 3. You have 3 of them, 1.5, 1.5, 1.5. That's 4. You have 4 of them, that's 6. It's been done as long as I've been alive and then some, I'm sure. All right. Well, let's do this. Let's test now. Just doing the program for through the diode. So we jumped up to 25 and then down to 17.5. Let's see what the diode drop is. Looks like it drops about a volt. Did you see that? Program again. 24 down to 16.7. So drops at just about a volt. So really, this is just going to be perfect. So I'm going to turn this on right here. And now that we're checking the voltage, now that we're checking on the gray, which is the voltage directly to the pin on the chip. And so here we go. I'm hitting the program. So let's see what we have. Right now we're sitting at 4.79 volts. That's good. And let's go to program. 25. See that? 25 the whole time. 25.42. Now, what did it start out at? Does it jump up higher? No. It started lower. Isn't that interesting? It like started out at 11 and then went up, as opposed to before without this, it jumped up to 25 and then dropped down. I can't explain that, but that's how this thing is behaving. One more time. See, it is sustaining 25 point some volts. So it's perfect. This in series is perfect. Now this is a fresh 9-volt battery. It still should measure exactly 9 volts, no problem. In order